Welcome back to Oceanic and Polar Experts. In this episode, we are looking to the dead water phenomenon. The dead water phenomenon is a physical phenomenon developing in fluids stratified in density. The term stratified in density means that the fluid density increases with depth. The phenomenon was first described by Norwegian explorer Fridtjof Nansen, who experienced it firsthand in August 1893, when he was on an Arctic expedition. According to Nansen, when caught in dead water, the ship seemed to be held back by an unknown force and did not respond well to steering. In usual calm weather and light cargo conditions, Fram could sail at speeds of 6 to 7 knots. However, when in dead water, the ship struggled to reach even 1.5 knots. They attempted various maneuvers to break free from the dead water's effects, but had little success. Nansen observed that dead water happened when a layer of fresh water rests upon the salt water of the sea. But people had no idea what the mysterious force was at that time. Now we know that Fram met a wave, but it is not a wave you can always easily see at the surface of the ocean. That's what made Nansen and his team so confused. It was an internal wave. An internal wave is a wave between two layers of water that have different densities. The melting sea ice provided fresh water at the ocean surface. The water at the surface was therefore less salty and had a lower density, while the water below was still very salty and dense. There was then an interface between the two layers of water. An internal wave was formed at the interface, and this wave took away some of the energy that was supposed to move the ship forward. Nansen became very interested in the dead water phenomenon after his expedition, and he found physicist and meteorologist Wilhelm Bjorknes to study this mystery. Bjorknes did not investigate this phenomenon on his own. Instead, he asked his student, Wilfred Ekman, to do that for him. Ekman therefore became the first person who studied internal waves in a lab. Ekman set up two layers of water in a water tank. The bottom layer was denser than the top freshwater layer. He dyed the bottom layer for easy identification of the interface. A model of the ship was made and attached to a rope, which was later pulled by Ekman. He could clearly see that internal waves were generated as a result. They interacted with the ship and produced a drag, causing abnormality in the ship's movement. Later, people learned more about the dead water phenomenon, realizing that when internal waves sway a ship back and forth, two drag phenomena can result. The first is called Nansen wave-making drag, which leads to a persistent but unusually slow progress of the ship, as experienced by Nansen. The second is called Ekman wave-making drag. As observed by Ekman, it causes speed fluctuations in the affected vessel. Modern scientists and mathematicians explored the drag phenomenon further in depth in a major project on the reasons why Cleopatra's large ships lost when they faced Octavian's weaker vessels in the Battle of Actium. The Battle of Actium took place in 31 BC, near Actium in Greece. In the battle, Roman general Marc Antony and Cleopatra VII, the Egyptian pharaoh, joined forces to fight against Roman military leader Octavian's fleet. However, they lost the battle, and Octavian emerged as the dominant figure in Rome. Eventually, he became known as the first citizen of Rome. Legend says that the defeat was due to remoras, or suckerfish, attached to the hulls of the fleet. However, some scientists suspect that during the battle, the Egyptian fleet may have encountered the dead water phenomenon, slowing them down. It is possible. At the place where the battle happened, the Bay of Actium had fjord-like features, and fjords are suitable locations for internal waves to form. The research carried out by scientists and mathematicians involves a mathematical classification of different internal waves and an analysis of experimental images at the sub-pixel scale for the first time. They found out that the speed variations of the dead water phenomenon are because of the formation of certain waves on which the ship moves back and forth as if it is on an undulating conveyor belt. Also, they discovered that the speed fluctuations are temporary. The ship will eventually return to the slow but consistent speed experienced by Nansen. Thanks for listening to Oceanic and Polar Experts. If you liked this episode, please give it a like and subscribe. See you next time.